Okay, so exponential function and graphs. So one of the very useful function we discuss in this course is exponential function. We're going to talk how to define the exponential function and then how to draw the graphs and then where we can use this type of function in day-to-day life. So if your function is defined in this way, where you have a base and then there is a variable on the exponent, that's called exponential function. For example, here you can see some examples down here. This all these functions are exponential because there is a base, positive base, and then there is a variable on the exponent. Because the variables, this variable, they are on the exponent, that's why it's called exponential function. Keep in mind, the base supposed to be positive and you know not equal to 1. If it's 1, then that would be very trivial function like 1. So it's not interesting. That's not going to be exponential function. And if it's negative, then that might give you complex number for the even power. That's why we just try to avoid that situation here while defining the function. So any function in this form is called exponential function, and these are some examples. How do you plot the graph? You just find out some points using your calculator and then plot them, and then you will eventually be able to see the graph. Basically, there are two different type of graph. If your base, let's say if your base is less than 1, then graph would be look like one of this. These are the three examples. So it's going down. So it's a going down. It's a decaying function. If the base is greater than 1, then your graph would look like one of this. These are the three examples. It's going up. Exponential growth. That's why it's called exponential function. Exponential decaying, exponential growing. One of the example, or there are so many examples of exponential function, but one of the example I can give you here is this future value we can calculate. And here, if the variable is time, then this is the exponential function and the variable is time. This is the exponential function with this base. Okay. When we try to use exponential function, we might see this number e, which is very useful number. This number is also called Euler's number, which was introduced by Leonhard Euler. This is an irrational number, and this is the value of the Euler's number. Okay, sometime we might have base this is greater than 1. That's the reason when you try to plot the graph would be look like this. Graph of e to the power x, it's same to the exponential function with the base greater than 1. And if the exponent has negative of x, which is the reflection of this graph, it goes down. So these are the things you have to keep in mind while dealing with the exponential function. So let's look at some example. How do you find e to the power 6 using your calculator? We know, on your different calculator, they have a different ways to use this. But for me, I just type e, that is the value of e, and then I take the power, whatever number I have given. In this case, it's a 6. Round to the 4 decimal place, it's a 403, 42, 88. 403, 42, 88. If you round to the 4 decimal places. Okay, these are the things you can calculate using your calculator. Graph of 2 to the power x, this is the exponential function, and only one of the graph is going up, so it's easy. This is also exponential function, but the base is less than 1, so it's supposed to go down. There are two graphs which is going down, a and c. You need to find out which one is the right one. Actually, for this one, a is right because the graph has to be above the x-axis. Here the graph is coming down. Okay, this is the graph you can find for this one. Is it's an exponential function, and you are adding 2 to the x coordinate, which is the shifting horizontally to the left 2 units. So start with the graph 2 to the power x and shift the graph 2 units to the left. So B is the only option you have. It's a transformation. How do you plot the graph? Click this, choose right type of graph. This is 2 to the power x, so it's supposed to be exponential growth. And then from these options, choose it's a horizontal shift. This is the horizontal shift, 2 unit to the left. Okay, 2 unit to the left. And what is the base? Base is 2. Right? Yeah. Save it and then check answer. That's good. Okay. This is also transformation, so I'm going to go to the next problem. Yes, e to the power x minus 5. So subtracting 5 from the y coordinate, it's a vertical shift down 5 units. So it's the graph of e to the power x is like this, and take this graph and vertical shift down 5 unit. That makes I think this is the only one option you have. So this is the, again, transformation of exponential function. First of all, start with 2 to the power x and then make the negative x, which is reflection across the y-axis, and then make negative of that, which is reflection about the x-axis, and then add 4, which is shifting 4 unit up. So that's what you do at the end. So reflect the graph of this across the y-axis and the x-axis, and then shift up 4 units. It looks right. Y-axis and then x-axis and then shift up. This is the only option we have, which is, so this is the graph. Start with this one, which is 2 to the power x. The base supposed to be here, it's base 2 instead of e. And now we are doing across the y-axis. So reflection across the y-axis, across the x-axis, and then vertical shift. This one is a vertical shift 4 unit up. 4 unit up. Save. So these tools are very, very helpful while plotting the graph of exponential function, and that's all for this section.